Hello, my name is Laura Moreno. I'm going to present my Steamboat project. Materials: Tetra Pak box, 1 can, 2 straps, 1 candle, 1 marker, scissor, silicone machine. Initially, we measure 8 centimeters and marker. We cut along the marks indicate above. Then we cut it in half. We fold it in half. Then we fold the sides, first the right and then the left. We poke the straps in the pocket at the top of the can. We glue the folds. We disassemble the bolts from the bottom and from the top and press. We cut the bolts in half. Here we shape our boat. After measuring, we make a hole with the scissors. We put the strap in the hole. We stick the candle. In the straps, we put water and cover. We put our boat in the water. And finally, we light the candle. Explanation: First law of thermodynamics: energy is neither created nor destroyed, it only transforms. The candle flame heats the water to its boiling point. It turns into steam, causing the molecules to occupy more space and seem to escape from the system. It reaches the necessary pressure to expel water and steam toward the straps. There remains a pressure difference between the system and atmospheric pressure. Every time steam is expelled, the ship receives forward momentum. The boat thus adjust width will be equal to the height at the beginning.
Okay, hello. For this home experiment, we gonna need a small wooden board, ruler, marker, a sealed can, a screwdriver or utility knife, screws, an empty can too, and a scissors and a wire. Okay, first we cut off the top and bottom of the empty can. From the leftover metal we cut out a circle like showing the video right now, and then use scissors to shape it into a propeller like this. Okay, right now we measure on the board, mark it as shown in the video like that, And finally we're gonna cut the wooden board. We gonna insert two screws on the sides, like showing the video, and tie some wire between them. Okay, then we're gonna repeat this step with two more screws, and just like in the video, under the wire and screws we place the base of the can that we previously cut. We make a small hole in the top of the sealed can and place it on top of the wire. A bit ahead of the sealed can, we place two more screws and stretch a wire between them, crossing it through the center of the propeller. We place a candle under the base of the can and light it. In the experiment, the heat generated by the combustion of the flame transfer energy to the water. The thermal energy causes the water to change into steam, which does work by turning the blades of the turbine, thus converting thermal energy into mechanical energy. The law explains how this energy exchange is conserved at all times. Physical principles involved heat transfer, phase change, energy conversion, practical applications, power generations, propulsion. The process in the experiment is a simple example of the power generation cycle, similar to a steam engine. Thermodynamics studies how energy can be converted from one form to another and how change in temperature and pressure affect this process.
Materials: a lead candle, a glass, a plate with a light, water. The candle thermodynamics experiment is a classic experiment that allows you to observe several physical and chemical principles, such as air convection, oxygen combustion, and the release of carbon dioxide and water vapor in addition to energy change heat.
What's up? 1. The candle goes out after a few seconds. 2. The water level inside the glass rises. Why does it happen? 1. The combustion needs oxygen. When the glass is closed, the available oxygen is quickly exhausted. 2. When the candle goes out, the temperature inside the glass decreases, which causes a contraction of the whole air. 3. This decrease is pressure inside the glass, creating a partial vacuum, and the water on the plate rises to equalize the pressure.
Concepts involved: first, law of thermodynamics, conversion of thermal energy wax into thermal and luminous energy.
Air convection, the whole air rises, which can be observed with the movement inside the glass. Pressure and volume change, law of ideal gas.
Hi, good afternoon. Today we want to share with you this experiment focused on the first law of thermodynamics. This law states that energy cannot be created or destroyed. It is only transferred from one system to another. For this experiment, we will need a candle, a glass plate, a baker glass, and water.
First, we must place the candle in the center of the plate. After that, we pour the water onto the surface of the plate. Then we light the candle and subsequently we place the beaker or glass, covering the candle completely inside the beaker.
In this case, when you extinguish the candle on the glass, the combustion consumes oxygen, as here. but it also generally a decrement in the internal energy of the gases adhere with the system. This loss of internal energy causes a drop in the pressure. As a result, the pressure and sign is greater at the pressure incident, and its pressure different draws water in the water to equality the pressure.
Materials used for the experiment were alcohol, cotton, orthopic, scissors, syringe, aluminum, a ladle, a nail, and scalpel, a toy car, and steel wire. How does the steam-powered car work? The car consists of a basic structure, like a toy car, on which a metal can is mounted. Acting as a boiler, a small amount of water is placed inside this can. When heat is applied, for example with candles, the water boils and turns into steam. This steam escapes through an opening in the can, generating a jet that propels the car in the opposite direction, following the principle of action and reaction. Thermodynamics analysis. First law of thermodynamics, conservation of energy. Thermal energy supplied to the system, heat, is transformed into internal energy of the water, increasing its temperature until it boils. The generally seen as kinetic energy that when escaping does work by moving the cart. Second law of thermodynamics, duration of processes. The process of converting heat into work is not 100% efficient. Some of the energy is dissipated as heat to the surroundings. This illustrates how use of energy decreases with each transformation, increasing the entropy of the system. Newton's third law, action and reaction. The scene that is expelled backwards exerts a force in that direction, and as reaction the car moves forward. Educational applications. This experiment is ideal for illustrating concepts such as transformation of thermal energy into mechanical energy, relationship between pressure, temperature, and volume in gases. It is a practical and visual way to understand how heat engines and steam engines work.
In this video, we will present a homemade thermometer design to ensure heat transfer and system using accessible materials and a simple procedure. To do this, we will need a container with a lead, water, alcohol, a swab, food coloring. Its construction consists of pure whole water and whole alcohol into the container with a lead, along with a little food coloring. A hole is made in the lead for the straw to pass through. This container is placed in hot water and then cool water.
It is observed that when the container is placed in the hot water, the liquid in the container begins to rise through the straw. This effect is related to the first law of thermodynamics, where heat increases the internal energy of the air inside the container, which raises its temperature. When heated, the air expands. The expanding air pushes the liquid in the extra of water, doing a small amount of work on the container environment. All this happens without losing energy.
It only transfers heat into internal energy and down into work. Unlike contact with cool water, when no reaction occurs.
Hello, I am Elizabeth Arboleda, and this video is inspired by the teacher's explanation in the classroom when she asked us the question, who need more heat? The system and the constant volume or the constant pressure. We are going to demonstrate the principle of the first law of the thermodynamic. The difference between the specific heat at the constant volume and the constant pressure, using cylinders as the closing system with the gas here. Here I have two cylinders with the same volume of the air at the room temperature, 23. In a syringe, the plunger is fixed so the gas cannot expand. This simulates in the constant volume system. In the other, the piston is free. This simulates constant pressure because the gas can push outward as it heats up. Here there is not friction from the piston, which is why we able to make it slide better. To simulate a closed system, we see the noses. I immersed both cylinders in the hot water for 19 seconds. This cylinder with the fixed plunger did not change in volume, but its temperature did increase. In contrast, this cylinder with the mobile plunger became expanded. That is, the gas did work by pushing the piston while it was heated. Therefore, to do the work, it requires more heat because some of this heat was used to move the piston. This proves the theory at the constant volume, as the heat is converted into internal energy. At the constant pressure, some of the heat is used to increase the temperature and the sun to do work, so a specific heat is greater than. Taking the equation for closed system, substitute internal energy. The internal energy over mass, cancel mass, and the obtain Cv. Interpolating to find internal energy, 1 and 2. It tells us that for ideal gases, Cp less Cv equals R. We find R universal over the molar mass of the air. We clear Cp and obtain is the value. Indeed, for there to be a change in the temperature of the gas, more heat must be applied at the constant pressure than at the constant volume.
Good morning. Next, I will present an experiment on the first law of thermodynamics. We will only need a bottle, a balloon, water, and a candle. This first law of thermodynamics establishes that one system can exchange energy with another through heat or work. Heat is the action of transferring energy from one system to the another. Work also transfers energy but using force when there is a displacement. Internal energy refers to the microscopic energy of the molecular scale. The payroll changes its size in relation to the initial size. Since the temperature increases inside the bottle, doing work towards the pump, causing to deflate. This satisfies force time displacement. The flame performs the function of transferring thermal energy, which means heat to the water bottle system.
A few
this
moments
allows
later.
the internal energy to change and work to be produced.
Thermodynamics experiment, ice fission.
This experiment is presented by Andre Mendoza Coronado, Valentina Marcela Torres Rico, and myself, Paulina Garcia Restrepo, for the subject of thermodynamics under the direction of the teacher Gina Incapié. Materials: ice cubes, salt, glass with water, and thread. The experiment presented below is very interesting. Initially, we will place water in a glass with the ice cubes, and on top, the thread and some salt. Then, we will wait approximately 2 minutes, and we will leave the ice with the thread. First, you should know that when you place the ice cube in the glass of water, two processes occur. One, the ice begins to melt, and the other, the water begins to freeze. These two processes occur simultaneously, which, from a thermodynamics perspective, means that they are in perfect thermal equilibrium. It should.
Hello, classmates. Today I will explain a home thermodynamic experiment, a steam-powered car made from aluminum cans. This car is made using two cans. One of them has a small hole and contains living water. The other holds a piece of can soaked in alcohol, which we eat with first. Both cans are mounted on bastions all they two roll. When we will the alcohol some cut, the air generates warm the can with water. The water started to boil and produces steam. The steam increases the production inside the can and sky will cover the hole. This jet of steam currents are upward in the opposite direction, which pulls the car forward. This experiment demonstrates how energy interforms according to the first law of thermodynamics. Energy cannot be created or destroyed or transformed. Here, the chemical energy from the alcohol turns into thermal energy. Heat. The thermal energy is converted into mechanical energy when the steam escapes and pulls the car. We also observe how gas handles heat as temperature increments, pressure increments, and with the steam to be split for falling. This experiment showed in a simple way how air can produce movement, a basic principle of thermodynamics. This is how the first steam unit was powertrain and speed worked. Project B, Jasmine Rojas and Verónica Jaramillo.
Experiment. Homemade steam engine by Maria Camila, Diana Carolina, and Luisa. Materials: small metal can, nails, wooden base, can light, plastic light, candle, wooden stick, paper, bed bags, silicone, hammer, needle, and water. Procedure: make a hole in the top of the can, through which we will extract the liquid and add water with the help of a syringe. As a second step, we must nail 4 nails into the wooden base and form a square. As a third step, it is important to keep in mind that we must make a paper sweep using rainbow paper, gum drops, and craft sticks. Once the sweep is ready, we glue it to our wooden base at the front of the can. For this next step, it is important to have a can light and a plastic one. The plastic one serves as a base so that the topic light is higher. Finally, we light the candle and the water inside the can will boil and come out through the wall in the form of steam, making the paper swirl. What are the laws of the thermodynamics? First law, conservation of energy. Thermal energy from heat, in this case fire, is converted into mechanical energy, i.e., heat is converted into work. It also fulfills second law, direction of process. Heat flows irreversibly from the hot surface to the cold. Furthermore, steam only does useful work as long as there is a temperature difference. This was our experiment. Thank you very much.